What's up everyone, and welcome back once again. In this video, I'm going to show you how we can use another tool for experiment tracking, and that is the weights and biases. Many of our projects that we have been doing, most of the time we have been using, in fact, I think all the projects we have been using MLflow for experiment tracking. And in those videos, I have highlighted how you can integrate MLflow to track your model training, model evaluation, as well as the model validation, and as well as how you can track all the artifacts that are generated in those steps or components during the entire machine learning development. So in this video, I'm going to try to integrate another tool, and that is the weights and biases, and see how we can again track those steps in our machine learning development. So I will track the model experiment where we are training the model itself. Then we can also track the artifacts generated from that, as well as the preceding step, which is the model evaluation. Again, we are going to track that, as well as the model validation, as well as and also all the artifacts generated from those steps. So weights and biases, I think it's not quite complicated, so I'm not going to go into a lot of details. So my goal is to just explain to you how you're going to implement this tool into your machine learning projects. So weights and biases, again, it's just simple. Just sign up if you don't have an account with weights and biases, or just log in if you already have one. So when you log in, I think you'll be taken to, I think this is the home page, if I'm not wrong. So let me see. I think this is the home page. And this is my account. As you can see, I've tried to run some experiments. So once you are at this page, you can see currently I do have this project, electricity bill, as well as the customer churn. So I think we are going to use this customer churn, but let me show you how we can, the first thing that you need to do is, once you set everything up, then I think you'll be taken to this page, which is the home page. Then you can see we have the overview, where you can see whatever you have been doing with the weights and biases. You can see the reports. I haven't prepared any reports yet. So for the projects, this is the main agenda here. So here you just need to create a new project. It's just very simple. Click on this, then the team give a name for your project, then project visibility, and then that's it. Then with that, click OK. Then you'll have created your project. So my project is this customer churn. And this is the project that we are going to be using. So once you have created this project, on your left hand side, you can see this dashboard. Let me try to see if I can increase the font. So this dashboard, you can see that we have the overview, workspace, runs, reports. We also have charts, jobs, automation, sweeps, artifacts, and all that. So once we are developing our project, then you will see how how we are going to be applying all these functionalities. Okay, so here the only thing that I think I'm very much concerned with is this, how to install the weights and bias library. So install the CLI and the Python library for interacting with the weights and biases API. So you first need to run this command in your terminal. I'm using a VS Code, so I'll be running this command in my terminal, then so that we can install the weights and biases. Then after that, we need to log in. So we will run this command, weights and biases login. Then you need to give this API key. So this key is totally different. My key will be totally different from yours. So make sure that I use your API key to run that. Then this is just an example of how you can integrate the weights and biases while tracking your experiments. But because we are doing another experiment, I won't delve much into this, but I'll just show you how we can implement that when we are dealing with our own project. Okay, so let's begin with it. Start with this. So pip install weights and biases. So I think that I've already done that. So I think pip install. So I think this one here. So pip install weights and biases. So pip install. So once you are done this, I think it will execute like this. Then I think at the end you'll see that successfully installed Docker and all these other information concerning weights and biases. So once you are done with that, then the second step is about this login. We need to log in. So I'll just copy this command, go back to my terminal. And I think I'll just clear it, CLS. Then I'll just include, copy that, weights and bias login. Then once you run that, you need to copy this API key. So I'll just copy it because I'll be required to enter this API key. So I'll just do a Control V, then enter. I think it's a secret command, so you won't be seeing it. But I think once you execute that, you should be connecting with your weights and bias account. I think want login. Again, it might take some time. I think that's it. So currently login as Miniquarks. So this use this one login dash relogin to force if you want to relogin. Okay. Then I think this is not recognized as an internal or external command. Anyway, yeah, I think I was not supposed to run this. Okay, so that's it. So I think we have now we have installed this, and then we have logged in into we have logged in using the API key. Then after that, so now we need to start the experiment tracking step. Before we begin on that, remember our config.yaml file. So we need to set up the configuration first before we proceed. So under the configuration, the only thing that we will be including is the weights and bias. So that will be the project name. So we can just include the project name. And for my case, I can just for the weights and bias. So the project name that is customer. Just call it customer Chan. That is my project name. So just make sure you include that in your config.yaml file. Then let's jump into the model trainer. So under model trainer, I think this is just the code for MLflow. So I'm not going to delete it. So in case if you want to maybe compare the MLflow as well as the one for weights and biases, then you can just do it. But I'm not going to delete it for this case. So we can just again start the process for the weights and biases. So model trainer, weights and biases. Again, as usual, the first thing. So for this case, I will be doing the weights and biases, but this is without the sweeps. I'll prepare another video to see how we can do hyperparameter tuning with the weights and biases. Okay, but just for an introduction, let's begin with this. So this is the weights and biases without a sweep. Then now we need to import. Now we need to, for the weights, just use the weights and biases. So for that, I'm just going to, now we need to import that. So import the library for that. So import, I think that's it, weights and biases, 1B. And after that, we need to add another requirement. This one, the one core. So weights and, so we can say add the requirement. So that is the one require. Just put it inside here. So that is, so that's another requirement when installing or when working with the weights and biases. So as usual, as you can see with the MLflow, we can just again copy this. I think the model trainer entity. So the next thing is the model trainer entity. So So our entity at data class model trainer config. Then remember, we need just to copy whatever we have listed under the model trainer step in our configuration file. So again, that is something different. So I'll just refactor this code. So the root directory, so that's the path, training data, validation data, the model name. I think those are the root directory, training data, validation data, model name. So we are not using the MLflow URI, so I just comment it. Then I think with this, the project name, yeah. So from here, let me just save this. So from here, the model name. Then these are the hyperparameters for the LGBM classifier. So remember, we are working with the classification model. So this, we are seeing how we can implement weights and biases for a classification model. Then let me go to my schema.yaml, params.yaml. Then there are some things that will be boosting type, max depth, learning rates, n estimators, objectives, so some multi-class classification, minimum sample split, minimum child weight. I think that's okay. Reg alpha, reg lambda, random state, mean child samples 20. Yeah, I think everything is okay. So just need to make sure that whatever we have listed there should be again what we have provided here. Then if it's a string, we define that it is a string. If it's an integer, we define that that's an integer, or if it's a float, again we just define that is a float. Then remember, we have introduced another parameter under the when we were preparing our configuration file. So that's the project name. So remember that I've just introduced that here. So the project name is on this one here. So then once we are done with that, we need to prepare the class, the configuration manager. So I'm just going to prepare the configuration manager. So I'm just repurposing the code that we used when when we were working with the MLflow. So it's not something that I'm changing significantly. So the configuration manager remains the same. So these are the files that the config. So this config contains the configuration parameters that we need in this script. Then the params contains the hyperparameters for the LGBM classifier. The schema contains, I think this is the columns names and as well as column names, as well as their schema. Where is the schema? So it contains, I think, schema. Yeah, it contains the column names, as well as if they are either a string or an integer or a float. Yeah. So again, we are reading those those data from the different YAML files. Then this is the data transformation config. So data transformation. Then after that, we do the model training. So under model training, you can see again. For the model training, we're only reading the configuration details as well as the parameters. So the hyperparameters for the LGBM classifier. Then we'll be creating these directories, as well as we'll be importing this data from the different params.yaml file. Okay. Then this is just the weights and bias, the project name. Okay. So once we are done with that, then we need to initialize so I'll be using the certified K fold. So once we are done with that, I need to first, there's something I'm missing here. So we need to create another class. So that class is the model trainer that will actually handle the training, the model training. So class model trainer. So the model trainer, the first thing we need to initialize it. So I'll just create model trainer. And after that, model trainer config. So we need to create another function that need to proper alignment. That one is good. So I think this one is okay. I'm just going to take you through all this. So the first, we are creating this class model trainer. Then this is the function. This the initiate model trainer method that so the initiate model trainer method is under the class model trainer. This method is responsible for training the LGBM classifier model. Then we also performing cross validation, logging the metrics using the weights and biases, and the saving the trained model. So this is where we start the run for the weights and biases. So run weights and biases. So we are initializing it. Then the project name. Then we are just going to read it from here, from the configuration file itself. Then project self.config project name. Then we are setting up the different configurations. So these are the different hyperparameters that we will be tracking when doing the model training. So after that, we need again to set up the LGBM classifier. So with the LGBM classifier, LGBM model, LGBM classifier. So this is all about when we will be doing the model training, we need to extract the different values from these params.yaml. So we need to be extracting these values from here. So that's why we are LGBM classifier. We are initializing it, and we are specifying that for these hyperparameters under the LGBM classifier, please go to the params.yaml file, extract those values, and use those values when training our model. Okay. Then after that, we need to initialize the certified k-fold cross validator. So we initialize that. So I'll be using a certified k-fold validator. So the number of split is 5, shuffled true, random state 42. Then we need to perform the certified k-fold cross validation, train the model on the training fold, validate the model on the validation fold, then evaluate. Okay, so that's the next step. So if you have been following through this, I talked a lot on this about when we are doing the experiment tracking with the MLflow. So if you want to get the entire explanation on that, I'll make sure to leave a description for that video in the description section, so that you might again go to there and see how we were explaining all this certified k-fold and all that. Okay, so this is just we first initialize the certified k-fold cross validator, then perform the certified k-fold validation, where we train the model on the different folds, then validate the model on the validation fold. Then after that, we run that, then we log the fold specific metrics in the weights and biases. Okay, then after we are done with that, the following steps are going to take. We are going to do the following steps. So make sure that everything is good. So after that, we'll print the average macro F1 score across all the folds that after doing the certified k-fold. Then after that, we'll print that. Then we'll log that average value using weights and biases. So you see run.log. So we're using the log function, and this the average F1 score is this one here. So the average F1 score is the sum of all the folds. Then we divide by the length. So if we are doing 5 folds, so the sum of the different folds divide by 5. Then we'll just print that so that we can see how our model is performing in the different folds. So that just gives you a clear picture of how your model might work on the entire data set. Then after that, we save on that. Then we retrain the model. So this model that we were training on the k-fold, this one here. So once we are satisfied that this model is working good based on the certified k-fold cross validation, then we can just assume, okay, let's train it on the entire training set to see if how it will be working. Then after that, we save the model. So model path. So we provide the path for that model. Then I use the joblib. So my file will be a .joblib. Then after that, we log the model metrics artifacts in the weights and biases, using weights and biases. Then after that, and just do something small, maybe logging some logging information to say that you see, once we are done with that, the model trainer completed and it's saved to this path. Then we need to end that run. So when we run we need to make sure that once we start a run, we need to end that run before we start a new run again. Okay, so once we are done with that, so we finish that run, then I think after that we just create our main execution block to ensure that weights and bias run is finished properly. So I think this one here. So if in case there is an exception, then we need to terminate the weights and bias first before anything else, before we start or do anything else. So that's it. That's how you can work with weights and bias. So the first thing that we did was to do the pip install weights and biases. Then after that, we need to log in. So you need to log in using your API key. So login, passing your API key, and that is okay. Then after you are done with that, you can now set up your code, your model training. Then after that, I think we are good to go. So I'm just going to execute this code in the terminal, and let's see what will be happening in the weights and biases. So how we track those experiments. So again, Python, just copy a relative path. So Python, paste it, enter. Once you are done, that will be the model trainer. Yeah, now you can see we have this is the third fold. So you can see again 0.91. This is the macro F1 score. So for the fourth one is 0.92 fold validation across macro F1 score. I think for the fifth fold again you can see 0.9. So you can see average is about 0.92. So the average is about 0.91792917, yeah, around there. So you can see that that was successful. So we are able to split our data into 5 folds, run on that, and you can see that we are getting good F1 score. Then after that, you can see that 175 root model trainer completed, saved on this path. So this is the run history of that. So with the weights and biases, so it's tracking that. You can see the different how it's tracking. When it's done, you can see find the logs at this. Then I think that's it. So let's go to our weights and biases and see weights and biases and see where is it? I think this one here. So this one is for the customer channel. So you can just refresh this. When we refresh, you can see the runs. So this is the time. This is the customer channel, yeah. Workspace. So when it comes to the runs, you can see the runs. You can see this one here. So this is a Deepstar. You can see the runs. This is the Deepstar. You can see the different hyperparameter, average score, summary. This is the hyperparameters that we are tracking. Now you can see the different folds. So fold 1, fold yeah, this one here. So this is the fold 1.92, fold 2, fold 2, 3, I think 4th and the 5th. So you can see all that here. This let's go to the runs themselves so that we're able to visualize that. When we look at the runs, you can see state finished, notes, user, tags created. You can see the different type of parameters for that. Okay, so when we click on this, then I think here you can have a good overview of that training. So you can see the different metrics for that. Then when it comes to the net traffic, all that disk training, so you can see all these. So with the weights and bias, you can see all this. This is just about the system metadata. So you can see it. Then processor, CPU, threads, all that. Okay. So if you want to add panels, you can add them. So if you want a line chart, bar chart, code, scalar chart, markdown, query panel, all that, you can get it from there. So that was just the first run. So that's it. So that's how you can integrate MLflow into your into tracking your experiments. So this was just an example of how you can introduce weights and biases. So you can see how this code is quite flexible. So you can see we've just not changed the core structure of the code itself, but we have just replaced the weights and biases with the so we have just replaced the ML flow with the weights and biases on just a specific points, but overall the code structure remains the same. So that's it for my side. So that's it from my side. I'm going to make sure that I push this code to Git so that you can also have it. So you can also look at it, then compare it with the MFlow one, see which one is better to maybe use. But since I discovered the weights and biases, then I do think that's one hell of a tool to use when tracking your experiments. Of course, you have just tried this with the classification example. You can also try it with the regression example. And uh, I'm also working on a new project on PyTorch. PyTorch, I think I'll be using PyTorch Lightning. So again, on that, we'll see how we can include weights and biases and how we can track the those experiments, and also do hyperparameter tuning there. So that's it for my side. Once again, thank you for your time. Thank you for taking time to watch this video. Subscribe to the channel if you haven't. Like this video, share it with friends and colleagues. See you in the next one. Have a nice time.